All right, so today we are starting topic 10, and topic 10 is expressions. So we'll be dealing with simplifying expressions and factoring expressions. And what this means is there's not going to be an equal sign on any of our problems. Our expression means that we are going to simplify it down so that way when it comes to solving later, we are ready to go. And so I want you to take a minute and write down our learning goal. It says that I can use the distributive property to expand algebraic expressions. So today we are going to expand algebraic expressions, and in a little bit you'll find out what that means. But I just want you to know that if you need to pause the video at any time to write stuff down on your Cornell notes, because you should be filling those in as you watch this video, you are more than welcome to do so. So you'll notice the first question on your Cornell notes is, what is the distributive property used for? And so the distributive property is used to simplify expressions. And so simplifying expressions means that we are setting up our expressions and combining like terms and getting ready to actually solve for our missing variable or our missing letter. But we can't do that until we have condensed our expression. So the ice cream example. The ice cream example I really like because I think it helps us remember the key points in the distributive property. And so when I think of the distributive property, I think of going to go get ice cream. So when I go and get ice cream, that's supposed to be me, with my brother, we don't share ice cream. You're not going to share an ice cream cone with your brother. At least I don't. So when we go to get ice cream, we make sure that we both get our own ice cream cone. And so that ice cream is given to me, and it is given to my brother. So now we both have ice cream. And so what's important about this is that this ice cream is being given to both people in the parentheses, which means it's being distributed to both people. So when we look at actually expanding expressions, if we have an expression that looks like this, which is 3x plus 2, that means I'm going to expand or distribute this 3 to both things in the parentheses by multiplying. So 3 times x gives us 3x. 3 times 2 gives us a positive 6. And so the reason that I wrote positive 6, it lets me know what operation I'm doing. And so since it's a positive, that means that I'm going to have a plus in between both of those numbers. But if it was a negative, then it would have been a subtraction sign. So my expanded form of my expression is 3x plus 6. And so this is going to be your answer today. And it is okay that we have an answer that looks like this. Not every answer has to just be one number. So you'll notice on your Cornell notes that you have the question, how do you use the distributive property? And we use it by multiplying each term by the number on the outside of the parentheses. And term just means each thing inside the parentheses. So there are 2 terms inside the parentheses of my ice cream problem, and there are 2 terms, an x and a 2, inside my parentheses. All right, so we're going to ignore this for right now, and we're going to actually do it ourselves. So we have negative 2 times negative 3y plus 5. So we are going to use the distributive property, and we are going to multiply this 2 through the parentheses. So negative 2 times negative 3 gives me a positive 6y. Always keep your variable. And then negative 2 times positive 5 gives me negative 10. And so you'll see that by deciding that this is a negative, it actually decided what operation I was going to be doing. So this is 6y minus 10. And this is my answer. You'll notice the way that digits says it. They distribute through the parentheses, and they actually show negative 2 times negative 3, negative 2 times 5, and then a negative times a negative gives you that positive, and a negative times positive gives you that negative, and then they dropped the negative because plus and negative is the same thing as subtraction. Whichever way works for you, both methods are actually the exact same thing, but use what is most helpful for you. When we're looking at this problem, we have A on the outside, and so we haven't had a letter on the outside yet, but I just want you to know it is the same thing. Don't let it scare you. We've had ice cream on the outside now. So again, you multiply A to everything inside the parentheses. So A times 2 gives us 2A. A times B, whenever we have A times B, just put those two letters next to each other in alphabetical order, because a letter next to something means multiplication. And so when we write this, also make sure that the number comes first before the letter, and then it's alphabetical order after that. So it is 2A plus AB. I want you to do the next two on your own. And when you're done with that, you may move on to down here. All right, so you'll notice that we have a fraction on the outside of our parentheses. Don't let a fraction scare you. We know how to multiply using fractions. We know that we multiply only our top term by our number, and then we keep our denominator if it's a whole number because it's over 1. So I'm going to rewrite this step by step, and then I'm going to show you kind of the quicker way of doing it. So I'm going to do it twice. So negative 1/5 times negative 5. I know a negative times a negative gives me a positive. So I have 1/5 times 5m plus negative 1/5 times positive 10 . And the reason that I write it like this is so that I can put it over 1, and I can multiply then straight across. Remember, with multiplication, we don't need same denominators. So 5 times 1 gives me 5m over 5 plus negative 1 times 10 gives me negative 10. 5 times 1 gives me 5. And I'm just going to keep simplifying this down. So I know 5 divided by 5 gives me 1, so those actually cancel out. 1 times m is just m. You can also write 1n if you want. I would not count that wrong. They're the same thing. And then negative 10 divided by 5 gives you negative 2. So this answer looks like this answer. If you are somebody who doesn't feel like they need to show all of this work because you understand multiplying fractions, I think of it's the same exact thing, except the way that I think about it is a little different. So I just take 1 times 5, which is 5, and 5 divided by 5, then just is m. And then 1 times 10 gives me -10, divided by 5 gives me 2. And so it's the same process, just less having to show work, but you do need to know that you multiply your top term by your whole number and then divide by your denominator, but that only works when they're whole numbers. There's actually one more answer on this one, and that is number 1, and I'm going to show you why. So we are multiplying by a -1/5. You'll notice that +10, that's +10. This is also a +10. And -5m, this is still -5m. So they didn't actually change the equation at all, they just rewrote it. Kind of like when you have 3 plus 5, which is 8, or 5 plus 3, which is 8. It doesn't matter the order as long as the signs are the same. So what is the expanded expression? An expanded expression just means that we've simplified the equation. And so this equation and this equation are the same thing. The only difference is we just simplified it down. And so when it comes to solving, this will be easier for us to solve later than having to go and solve for this. And so it's just getting us ready to actually solve an equation. So this is digits explanation. It's exactly what we just learned. It talks about how you distribute from the left, which is what we've been doing, but if it falls behind the equation, you also can still distribute from behind or from the right. And then we also can distribute letters through the parentheses. It is not just numbers. And so this is everything that we've already done in our notes. It's just Digit's way of reminding you of it. So I want you to solve this one on your own. And we're going to go over that on Monday. And then let's check out some more problems. So an architect draws plans for extending a rectangular deck. So right now their deck is only this, and they want to make it larger. The X represents the increase in meters of the length. And so we are going to use this expression, which they actually got from here. So they took the width and they're multiplying the width by the length, and the length is this plus this amount because we don't know what it is yet. And so that's where they got this equation. All right, so what does each factor represent in the expression, and what does the expression represent? So each factor, a factor is what we're multiplying by. So we have two factors. We have 3.7 and we have what's inside our parentheses. And this is representing our length and our width. And we know that when we multiply length times width, this is our area. And so that's what the expression is representing, is the area. I want you to go ahead and try part B by distributing through the parentheses. And then after that, you can start homework.